Good morning. Thank you, Carrie. Thank you all for coming. So today I'm going to be talking about residential wood-burning emissions in Utah's valleys. Specifically, I'll talk about their levels, their contributions to PM 2.5, and how this contribution varies between days where we have a ban on wood burning and days where we have no ban, all of which is essential in determining how important is wood smoke in PM 2.5, which in turn is important for policy and emission reduction strategies. So let me first start with a brief overview on residential wood burning emissions and their role in primary PM 2.5. So in Salt Lake County, residential wood combustion accounts for about 14.3% of primary or direct PM 2.5. And to put it in perspective, this contribution is almost comparable to that from mobile sources, suggesting that residential wood combustion is an important component of direct PM. And most of these emissions from wood combustion, so they're actually derived from fireplaces. So a survey that was recently conducted by the Utah Division of Air Quality showed that fireplaces are the most popular wood-burning device in Utah's 7-county non-attainment areas, followed by inserts and stoves. And emissions from these fireplaces can actually be quite significant. To produce the same amount of heat, fireplaces emit about 6 times more emissions than uncertified wood stoves. And they also emit about 3,000 times more emissions than gas furnaces to produce the same amount of heat. So really, emissions from fireplaces can be quite significant. And of course, they become even more important during our wintertime inversion event. So the objective of this study that we conducted at DAQ was to determine the contribution of wood smoke to PM 2.5. So in other words, what we were trying to determine was, is wood smoke really an important component of PM 2.5? Should we target wood smoke for emission reduction strategies? And we also looked at how this contribution varies between days where we had a ban on wood burning and days where we had no ban. So current regulations include a voluntary ban on wood burning when wintertime PM 2.5 levels reach 15 microgram per cubic meter. Then a mandatory ban is issued when the PM levels rise to 25 micrograms per cubic meter. So to determine this contribution of wood smoke to PM 2.5, we collected 24-hour PM 2.5 samples at 4 different sites: Logan, Brigham City, Hawthorne, and Linden. The samples were collected for almost a year-long period at the Hawthorne site and for just the winter season at the remaining 3 sites. And all samples that were collected were analyzed for levoglucosan, which is a tracer that is uniquely associated with wood burning. So in other words, this is a tracer, for instance, that can be used to distinguish between smoke that is coming from cooking and smoke that is coming from wood burning for residential heating. So the presence of this tracer, levoglucosan, indicates basically wood burning activity. Now, to determine the contribution of wood smoke to PM 2.5, we first decided to focus on the Hawthorne site, which is also a speciation network site, meaning it's a site where we routinely collect 24-hour PM 2.5 samples. So we collect samples at this site every 3 days and analyze them for 30 chemical species that include a large suite of ions, metals, and ECOC. So the idea here was to take this chemical data that we collect at the Hawthorne site, take this data along with the levoglucosan data, and again, levoglucosan is a tracer for wood smoke, take this data and put it in what is called a PMF model, which is a model for determining and apportioning sources to PM 2.5. So we took this data, used it as input variables in PMF, and ran PMF to determine the contribution of wood smoke and other major PM sources like mobile sources and other chemical species like ammonium nitrate to PM 2.5. So we ran PMF, and we're at using the data collected at the Hawthorne site, and we were able to determine a clear, unique source profile for wood smoke. And this is shown in the top panel. So think of this as a chemical fingerprint for wood smoke. So what you're looking at here is basically a source profile for wood smoke that is clearly dominated by levoglucosan. So the presence of levoglucosan in high amounts in this profile clearly indicates that this is a profile that is uniquely associated with wood smoke. And this profile also exhibited a temporal behavior of what we would expect for residential wood burning. Shown in the lower panel here is the time series for wood smoke concentrations over year-long period at the Hawthorne site, and you can see that the concentrations rise during winter and then drop down to a minimum during summer, which is typical of wood burning for residential heating. So these results basically tell us that we were able to identify a clear factor for wood smoke. Now, but what about the contribution of this wood smoke factor to total PM2.5? So this pie chart here shows the percent contribution of major PM species and sources to total PM2.5. And you can see that PM2.5 is mostly dominated by secondary sources, ammonium chloride, ammonium nitrate, ammonium sulfate, which together account for more than 50% of PM2.5. They account for about 60% of total PM2.5. However, while this PM2.5 is dominated by secondary sources, wood smoke was the major component among primary sources, accounting for about 16.2% of the total PM2.5 on average during winter. And this contribution is even higher than that from mobile sources, indicating that wood smoke is a significant contributor, at least among primary sources, to total PM2.5. Now, how does this contribution actually varies between days where we had a ban on wood burning and days where we had no ban? So the plot on the left here shows the percent contribution of wood smoke in total PM2.5 at the Hawthorne site during days where we had a mandatory voluntary ban on wood burning and days where we had no ban. And the average over the entire winter is also shown. The plot on the right shows the actual concentration, so the actual levels of wood smoke, again at the same site and again during days where we have a ban and no ban on wood burning. So looking at the plot on the left, you can see that the percent contribution of wood smoke to PM2.5 actually varied from a low of about 6% during mandatory days to a high of about 22% during days where we had no ban. And this is mainly attributed to the change in composition of PM2.5. During mandatory ban days, which correspond to high pollution episodes, ammonium nitrate becomes a more significant component of PM2.5. And so as the fraction of ammonium nitrate in total PM increases, the fraction of wood smoke actually drops down. However, while the percent contribution of wood smoke total PM2.5 was quite variable between days with a ban and no ban on wood burning, its actual concentration showed a different behavior. The actual levels of wood smoke during mandatory days were quite comparable to those during no ban days, averaging about 1.2 micrograms per cubic meter. So this basically potentially tells us that there's one, wood burning activity going on during days where we're supposed to have a ban on wood burning, and second, this tells us that wood smoke levels remain significant during no ban days. Now, what about the other sites where we had no chemical speciation data, and so we didn't have a large enough data set to work with and to run PMF, and so to determine wood smoke contribution? So how can we determine wood smoke contribution to total PM at these sites? So the idea here was to use the source profile, so the chemical fingerprint for wood smoke that we determined at the Hawthorne site using PMF, use this profile to derive an emission ratio for levoglucosan PM2.5, and then adjust this ratio for the proportion of appliances and their usage in at the non-Hawthorne site, and then use this adjusted ratio along with the levoglucosen that we measured at these sites to determine wood smoke. So we applied this approach, and we're able to determine wood smoke percent contribution, shown here on the left, to PM2.5 at North Provo, Brigham City, and Smithfield, again during days where we had a ban and no ban on wood burning, and on average during winter. And on the right is the actual concentration, so that's the actual levels of wood smoke, again at the same sites and during days where we had a ban and no ban on wood burning. Now, similarly to what we observed at the Hawthorne site, you can see that the percent contribution of wood smoke to total PM2.5 varied from a low during mandatory days and increased to a high during days where we had no ban. And levels were quite high at the North Provo site, reaching about 36% at North Provo during days where we had no ban. And again, this is attributed to the change in PM composition during the high PM episodes, such as what we observed during mandatory days. Ammonium nitrate becomes a more important component of PM2.5, so the fraction of wood smoke drops. However, as we observed at the Hawthorne site, the actual levels of wood smoke during mandatory days were overall comparable or even greater than those observed during no-ban days. And levels were also spatially variable and were mostly overall higher at the North Provo site during no-ban days, reaching a high of about 2.5 micrograms per cubic meter. So again, this tells us that we, one, possibly may have wood burning activity occurring during mandatory burn days, and second, wood smoke levels remain significant during days where we have a ban on wood burning. So to conclude, basically, our results showed that that wood burning levels remain significant during days where we have a ban on wood burning. And these levels tend to be highest at the North Provo site, followed by Smithfield, Brigham City, and Hawthorne. And these levels, the percent contribution of wood smoke to PM2.5 reached a low of about 6 to 11% during mandatory days and increased to about 11 to 21% on average during winter. So now where do we go from here? So what's next? So having determined the contribution of wood smoke to PM2.5, to total PM2.5, the next step is to actually see the impact of a wood stove change-out program. So if we were to, on reducing PM levels, so if we were to have a change-out program where we change our existing wood-burning devices into low-burning ones, how much would that reduce PM2.5 levels? So this is work in progress. It builds on these current results. So this is something we're working on through air quality modeling, and we're going to consider 3 different scenarios. First, where all existing wood-burning devices are converted to EPA-certified devices. And then we considered a second scenario where we have a full conversion to gas stoves. And third, we'll consider a more realistic scenario where we have a conversion to a combination of EPA-certified stoves, gas stoves, and we'll also consider an addition of retrofit technology. So this is work in progress. And finally, I would like to acknowledge the air monitoring section at the Utah Division of Air Quality for their help with the samples collection. And I also would like to acknowledge the Utah State Legislature for providing funding for this work. Thank you, and I'd be happy to take your questions.